Section 6.3, Solving Systems Using Elimination. The 4 steps for using elimination are to write the systems so the variables are aligned, eliminate one of the variables to solve for the other variable, substitute the value of the solved variable back into the original equation and solve for the other, and then write your answers in ordered pair. So here, the key to elimination is making sure you have a variable, whether it be x or y, where they have the same coefficient number but with opposite signs. So in this case, we've got negative 4y and positive 4y. And what we're going to do is we're going to add straight down, because when we add straight down, those two should cancel out, and we only have to then worry about one variable, and that one variable being left. So adding straight down, 3x and x become 4x. These two cancel out to give us 0. And then here we have equals 10 plus negative 8, or 10 plus negative 2 is 8. So in reality, we're left with 4x equals 8. And so now we solve this for x. We divide by 4. We get x equals 2. Okay, so now that we know what x equals, to solve for y, all we have to do is plug this back into one of the equations and solve for y. So let's plug it back into the second equation. So the second equation was x plus 4y equals negative 2. So I'm plugging 2 in for x, so I've got 2 plus 4y equals negative 2. So to get rid of this 2, I'm going to subtract 2. So I've got 4y equals negative 4. I'll divide by 4, and I should get y to equal negative 1. So my ordered pair solution for this system is 2, negative 1. Let's try another one. Same idea here. We're going to add straight down to eliminate, and we want to make sure that we have one variable that has opposite signs but the same coefficient number. So 3 and 3, positive, negative, these should cancel out. So we'll add straight down. So y plus 2y is 3y. 3x and negative 3x cancel out, equals negative 2 plus 14 is positive 12. We're going to divide by 3 on both sides. We should get y to equal 4. Now that we know what y equals, we're going to plug it back into one of the equations to solve for x. So in this case, I'm going to plug it back into the first equation. So I've got y plus 3x equals negative 2. So I replace y with what it is. So 4 plus 3x equals negative 2. I subtract 4 from both sides. And I've got 3x equals negative 6. I'll divide by 3. And I get x to equal negative 2. So that means my ordered pair solution here is negative 2, 4. Sometimes the variables have the same coefficient, but they do not have opposite signs. So it becomes necessary for us to multiply one of the equations by negative 1 to change the sign of the variable we need. So let's look at an example of that. So in this example, we have 2x plus y equals negative 5, and 2x minus 5y equals 13. The first two values here are our x's. Both have a coefficient of 2, but they're both positive. So I want to change the value of one of them to a negative in order to make sure they cancel out when we eliminate. To do that, I'm going to multiply the second equation by negative 1. When I do that, I multiply this number by negative 1, so it becomes negative 2x. This becomes a positive 5y, and then I get a negative 13. So everything gets multiplied by negative 1 in the second equation. Now I can eliminate. Adding straight down, that becomes 0. This becomes 6y. This here is negative 18. And so now I can solve. I really don't need to worry about the 0, so I can get rid of it. And so to solve this, I just need to divide by positive 6. And so I get y equals negative 3. Now that I know what y equals, I can plug it back into either equation to solve for x. So let's use the first equation. 2x plus y equals negative 5. I'm plugging this in for y, so I've got 2x plus negative 3 equals negative 5. To undo the negative 3, I'm going to add a positive 3 to both sides. I've got 2x equals negative 2. Divide by 2 on both sides, and you get x to equal negative 1. So my ordered pair solution to this problem becomes negative 1, negative 3. In the next example, we have y variables with the same coefficient, but they do not have opposite signs, so it becomes necessary for us to multiply one of the equations by negative 1 to change the signs. So let's say we multiply the second equation by negative 1 again, which means it'll make this one a positive 2x. We get negative 3y, and then positive 5 here. So now we can eliminate straight down. So 3x plus 2x is 5x. 3y, negative 3y is just 0. 15 and positive 5 is 20. We're now going to divide both sides by 5. And we get x equals 4. We still need to find out what y equals, so we're going to solve the first equation for y by plugging in what we know for x. So x is 4, so that's 3 times 4 plus 3y equals 15. 3 times 4 is 12. We got 3y here equals 15. We're going to subtract 12. We've got 3y equals 3. Divide by 3, y equals 1. So we get the ordered pair solution here for 1. In some cases, you're going to find that you need to multiply one or both equations by a number other than just negative 1. So let's say the numbers don't match up at all. Sometimes you have to double the entire value of one equation or multiply the entire equation by a negative 3 in order to make sure you have opposite coefficients somewhere so that your variables cancel out. At least one of the variables cancels out. So in this example, we've got x plus 2y equals 11 and 3x plus y equals negative 5. None of my variables have the same coefficient. One of them has opposite signs, but they don't have the same coefficient. So in order to get anything to cancel, I'm going to try multiplying this top equation by 3. So that way my x variables should cancel out when I'm done. So that changes my equation. So the first equation changes from what it was to 3x plus 6y equals 33. Now I should be able to eliminate straight down, and I'm eliminating using these two equations, the second one and my new one. So negative 3x, positive 3x cancel out. Y and 6y gives us 7y. Negative 5, positive 33 gives us 28. I'm going to divide both sides by 7, and I've got y to equal 4. Now that I know what y equals, I'm going to plug it back into one of the equations. I'm going to use the second equation. So 3x plus y equals negative 5. So 3x plus 4, since we know y equals 4, equals negative 5. I'm going to subtract 4 from both sides. And I've got 3x equals negative 9. Negative 3x equals negative 9. Divide by negative 3. And you get x to be 3. So our ordered pair solution here is 3, 4. The same situation occurs in the second example. None of my variables match up, none of them have matching coefficients, but the x values are opposites, meaning one's positive, one's negative. So for this problem, if I multiply the entire second equation by 3, I should be able to cancel out my x's again. All right, so let's keep in mind that the first equation stays the same, but my second equation is going to change here. It's going to become negative 3x plus 3y equals negative 6. And so now I'll eliminate straight down. So the x's cancel. The x's cancel, and I get 5y equals, well, positive 6, negative 6 is 0. So now I divide both sides by 5, and I get that y equals 0. Now that I know that y equals 0, I'm going to plug it back in. So let's say I'm going to use the original second equation. So negative x plus y equals negative 2. So I'm going to plug in 0 for y, so I get negative x plus 0 equals negative 2. So that means negative x equals negative 2. In this case, I know x equals positive 2. So my ordered pair becomes 2, 0. In this equation, neither of the coefficients match, and we have opposite signs in the x values, but there seems to be a problem because if there's nothing I can multiply one equation by to make it match the other. In this occurrence, I'm going to have to multiply both equations by something. So for this one, let's say I want to make my x's cancel out. Well, if I multiply the top equation by 2 and the bottom equation by 5, I should be able to cancel out a negative 10x and a positive 10x. So that means I'm changing both equations. So the top equation becomes negative 10x plus 4y equals 64. The bottom equation becomes 10x plus 15y equals 50. And so now I'm going to eliminate straight down. So 10x, negative 10x is just 0. I've got 19y equals 114. Well, in this case, I'm going to divide both sides by 19. And I should get y to equal 6. Now that I know what y equals, I'm just going to plug it back into one of the equations. Let's say I want to plug it back into the second equation. So 2x plus 3 times 6 equals 10. 3 times 6 is 18. I'll subtract 18 from both sides of the equation, and I get 2x equals negative 8. Divide by 2, and so x equals negative 4. So my ordered pair here becomes negative 4, 6. Next example, the same thing is true here. There isn't a single thing I can multiply either equation by individually to make them match the other. Instead, I have to multiply both equations by something. And so in this particular problem, we have options. We can either try to cancel out the x's or the y's. Let's say this time I want to cancel out the x's again. So to make the x's match, I'd have to multiply the top equation by 3 and the bottom equation by 2. So once again, I got to change both equations. So the top equation becomes 6x plus 10y equals 52. Oops, I'm multiplying by 3, not 2. Sorry about that. So it becomes 15y equals 78. That's better. The second equation, I'm multiplying by 2, so it becomes negative 6x minus 8y equals negative 50. So now I can eliminate straight down. 6x, negative 6x is just 0. 15y, negative 8y becomes 7y. 78, negative 50 becomes 28. There we go. And so now the only thing I have to do is divide both sides by 7, and I get y to equal 4. Now that I know what y equals, I'm going to plug it back into the first equation. So 2x plus 5 times 4 equals 26. 2x plus 5 times 4, which is 20. So it's 2x plus 20 equals 26. I'm going to subtract 20 from both sides. I've got 2x equals positive 6 divided by 2, you get x equals 3. So your ordered pair becomes 3, 4. Paige has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet. The cardstock costs 75 cents per sheet. How many sheets of each can she buy? So this is another one of those problems where we have to deal with two different situations. Money and then total number of items, sheets of felt and cardstock. So let's say F is felt and C is cardstock. So that means for sheets of felt and cardstock, we know that the number of felt stock or number of sheets of felt plus the number of sheets of cardstock should equal 12 total sheets. So we have our quantity down. Now we'll talk about how the money comes into this. Well, we know that felt cost 50 cents per sheet, where cardstock costs 75 cents per sheet, and you spend a total of, or Paige spends a total of $7.75. So these become our two equations. We have one dealing with money and one dealing with quantity. And so now to use elimination, I want to try to create opposite coefficients here. So remember that the F and the C in the second equation both have 1s attached to them. So if I want to change one of the equations, let's say this top one, so that it'll cancel out somewhere with the second one, I could multiply by -2. So when I do that, I end up with the equation negative F plus negative 1.5C equals negative 15.5. So this is the replacement for the first equation. And so now I can cancel out straight down. So 1F and negative F cancel out. Here I've got negative 0.5C equals negative 3.5. I'm going to divide both sides by negative 0.5. And I get the number of sheets of cardstock purchased was 7. So if Paige purchased 7 sheets of cardstock, that only leaves behind 5 sheets of felt, because she bought 12 total sheets. Okay, so we've got 7 cardstock and 5 felt.